Okay, so here's some examples of rationalizing the denominator. So you know this one for sure up here. I mean, all you just do is multiply by the conjugate. So what you do, square root of 3 plus square root of 2, square root of 3 plus square root of 2. So what you have is 4 root 3 plus 4 square root 2. And that's all over 3 minus 2. And that's just going to give me 1, right? So that's really just 4 root 3 plus 4 root 2. And there you go, ladies and gentlemen. That's the simplest way of that's the simplest way of rationalizing the denominator. But has it ever occurred to you just to rationalize the denominator of a nested square root like this? It is still possible to rationalize the denominator. All you got to do, I'm going to rewrite this in red. All you got to do here is get rid of this first square root that's nesting the other square roots inside. I know this is going to be a mathematical mess. So what I do is multiply by this nasty looking square root, right? And I get this nested radical mess on the top. And that gets rid of that first square root in the denominator. See that? But see, I still have rats in the basement. I'm going to get blue for this. So, square root of the square root of 6 plus the square root of 2 all over just the square root of 6 plus square root of 2 outside the radical in the denominator. All I have to do, multiply by the conjugate. Square root of 6 minus square root of 2, square root of 6 minus square root of 2. And see, this is where things are going to get very, very messy, folks. Because see, you got to use distributive property to get this here. How am I going to do this? Now, I could do it this way. Watch this. Square root of 6 times square root of 6 plus square root of 2 minus square root of 2 square root times square root of 6 plus square root of 2. And that's just all over 6 minus 2, which gives me 4 in the denominator. Now, this is going to require distributive property. But how in the world am I... with a nested radical? Really? Well, how could I do this? Well, if it's the square root of 6 times the square root of 8, you can actually multiply inside the radical. the square root of 6 times 6, that would just give me 6 inside. But it's inside another square root, so wouldn't... I'm kind of confused. That's really the square root of 6 times the square root of the square root of 6. Yeah. I think this is a good enough answer. It's not worth the hassle of trying to multiply a square root of like a nested square root. So I think this is a reasonable enough answer. This is going to be equal to exactly square root of 6 times the square root of the square root of 6 plus the square root of 2 minus square root of 2 times the square root of the square root of 6 plus the square root of 2. And that's all over 4, right? Because that was just 6 minus 2 in the denominator. And here's where things start to get really haywire. 3 over the cubed root of 2 minus the square root of 2. Well, I could try fractional exponents for this one, right? I can say that this is 3 over 2 to the 1/3 minus 2 to the 1/2, right? How would I rationalize something like this? Well, first of all, I have to get rid of both the cube root and square root. How could I do this? See, this is what... Yeah, this gets me into a mathematical nightmare. If you could solve this one, just be my guest, guys. I mean, if the indexes are not the same in the radicals, then this is going to get me into a mathematical nightmare. So, just be my guest, guys. Thank you. Peace and good evening.